Hello everyone, how are you? I hope you all are fine and doing well. I'm Poonam Sharma, your science teacher. Welcome you again another session of chapter number 2 of acid, bases and salts with you. Now in previous class I started with this chapter acid, bases and salts, in which I've explained you about properties of acids, how they react with the different substances, and what their physical and chemical properties. Now, in today's class, I'll continue with the same topic. I hope you have revised whatever I taught you in previous class. So these topics we have already covered. I discussed few questions also, which are important according to exam point of view. So these were the questions which I have discussed with you. Now I'll continue with the discussion of question answer part. Question is, equal length of magnesium ribbon are taken in two test tubes. So we have two test tubes, A and B. Sulfuric acid is added to test tube A. So we have sulfuric acid in test tube A and carbonic acid in test tube B in equal amounts. So the amount is also equal. Identify the test tube showing vigorous reaction. Name the gas liberated in both the tubes. How will you prove its liberation? Write chemical equations for both reactions. Out of the two acids taken above, which one will have lower pH value and lower hydrogen ion concentration respectively? Now, if we have two acids in different test tubes, in test tube A we have sulfuric acid, in test tube B we have carbonic acid. So, out of these two acid, this one is strong acid and this one is weak acid. Strong and weak acids I have already discussed with you in previous class, and if you have not revised, please revise it today. So strong acid show more vigorous reaction, more reactive acid, more vigorous reactions will be shown by that particular acid. So in this A test tube, because H2SO4, which is a sulfuric acid, it's a very strong acid, so it shows more vigorous reaction in comparison with the test tube B, in which carbonic acid is present, which is a weak acid. Now, next is give reason to support your answer. As I told you, because H2SO4 is a strong acid. And why this H2SO4 is a strong acid? Any guess? This H2SO4 is a strong acid because it ionizes completely in water. So that's why we call it a strong acid. And if you're talking about weak acid, it partially ionizes. That's why it's a weak acid. And name the gas liberated in both the tubes. How will you prove its liberation? So when acid reacts with any metal, so magnesium is a metal here. As you know very well, we have already discussed about metal in previous chapter also. So when any acid reacts with metal, it produces hydrogen gas. And how can you detect its presence? In last class I told you about test for evolution of hydrogen gas. There was a test. If you remember, I'll show you that test again. Yes, this was the test. So when acid react with metal, there is an evolution of hydrogen gas. And how can you detect its presence? If pop sound is produced, so it shows the presence of hydrogen gas in that reaction, or liberation of hydrogen gas in that particular reaction. And now next is write chemical equations for both reactions. So these are two chemical equations. Magnesium when react with sulfuric acid. So magnesium being more reactive than hydrogen, it can displace it and attaches itself with sulfate and it becomes magnesium sulfate. It becomes magnesium sulfate and hydrogen gases evolve. Second one is magnesium when reacts with carbonic acid. Again, this magnesium displaces hydrogen and it becomes magnesium carbonate. It becomes magnesium carbonate. And hydrogen gas is evolved. So in both the cases, as you can see, hydrogen gas is liberated and we can show its presence by keeping one this burning matchstick near the reaction, and if some pop sound is produced, so that shows the presence of hydrogen gas. And the next is out of two acids taken above, these two acids are sulfuric acid and carbonic acid, which one will have lower pH value? More acidic substance, that lower pH value. So this pH scale I'll discuss later. So H2SO4, sulfuric acid, it have lower pH value because it's more strong acid. And lower hydrogen ion concentration. So if acid is weak, obviously it has low hydrogen ion concentration in it. So carbonic acid will have lower concentration of hydrogen. So I hope this question is clear to everyone. Next is explain the action of dilute hydrochloric acid on the following with the chemical equation. First, I've just explained to you, we have already discussed. Let's do it again. If magnesium reacts with hydrochloric acid, so again, being more reactive, it displaces hydrogen, combines with chlorine, it becomes magnesium chloride and hydrogen gases evolve. Right? This is gaseous form, not a solid form. Then second is sodium hydroxide. So when sodium chloride and water will be formed. Now sodium hydroxide, this is NaOH. The formula of sodium hydroxide is NaOH. When it reacts with dilute hydrochloric acid, again being more reactive than hydrogen, the sodium can easily displace it and combines itself with chlorine. It results in the formation of sodium chloride, which is already written here, and water is formed. Another is crushed eggshells. Crushed eggshells are calcium carbonate. So when calcium carbonate reacts with hydrochloric acid, so calcium being more reactive than hydrogen, it can easily displace it and combine itself with chlorine, it becomes calcium chloride. And then this water is there, plus here carbon dioxide gas is involved. Okay. So these are the reactions when these different substances react with hydrochloric acid. So when carbonates react, they produces carbon dioxide gas. When these metals react, they produces hydrogen gas. Okay. Next is 15 ml of water and 10 ml of sulfuric acid are to be mixed in a beaker. State the method that should be followed with reason. What is this process called? If you remember, I discussed one term with you, dilution or dilute. It means mixing of water. If we are adding water in any substance, that process is known as dilution. So here, if 15 ml of water, it means just see the quantity of water is more than that of the acid are to be mixed in a beaker. State the method that should be followed with reason. We need to add, we have this test tube in which 15 ml of water is present and 10 ml of sulfuric acid. We have two test tubes. It contains 15 ml water and it contains 10 ml sulfuric acid. So the best method to mix them together is adding acid into water slowly. We cannot add water into acid. And what's the reason behind it? See, dilution. Dilution is a process in which we are adding water. So that process is known as dilution. So when we are adding acid into water, it liberates lots of heat. So which results in any accidents. So to avoid those accidents, we need to add acid into water, not water into acid. The best method is we should add acid slowly into water because it liberates less amount of the heat, and whatever heat is liberated, that can be absorbed by water. So there will be no accidents. So that's why we need to use this method only, in which we are adding acid to water. If we are adding water to acid, then it liberates lots of heat, tremendous amount of heat energy is released, which causes severe accidents. So to avoid those accidents, we use this method. And the method which is involved in this is known as dilution. So dilution is a method in which we are adding water. So I hope this is clear to you. Now, before I start with bases, few more points I would like to discuss with you regarding acids. So we are saying acids are those substances which contain hydrogen ions and they can easily conduct electricity. So it means if any substance which has hydrogen in it, so they can easily conduct electricity. Is it true? No, it's not true. How can we prove that? See, just take two beakers. Take two beakers and here you can attach electrodes and then combine it with battery, and here we have bulb, then combine it with this. Again similarly in this one also we are connecting with battery. Here we have bulb which acts like an indicator, which shows that whether the reaction is going smoothly or not. So if we are talking about these two beakers, in this beaker you can take HCl or H2SO4 or nitric acid, any acid you can take. And on the other hand, you can take glucose solution. So when we connect these two terminals, now it results in the glowing of a bulb. Here the bulb will glow, which shows that these acids are capable of producing electricity due to the presence of hydrogen ions in them. And on the contrary, if we are talking about glucose, after connecting these two terminals, there is no glowing of bulb takes place, which shows that although in glucose hydrogen is present, instead of it C6H12O6 is the formula for glucose, and although hydrogen is present, but still it cannot conduct electricity through it because it does not have hydrogen ions. So that's the reason why it will not conduct electricity. So it's not necessary that if any substance which has hydrogen, it can conduct electricity. Only those substances which has hydrogen ions in them, they can conduct electricity. And similarly, we are talking about rainwater. Now tell me, out of rainwater and distilled water, out of these two, which water can conduct electricity through it? It is purely based on this concept only. Yet in rainwater, gases are present. Carbon dioxide, sulfur dioxide, oxygen, n number of gases are present. So when they combine with water, it results in the formation of acid. And as a result of which, rainwater can easily conduct electricity. While if we are talking about distilled water, it is devoid of hydrogen ions. There is no dissociation of hydrogen ions takes place. That's why distilled water cannot conduct electricity through it. So these are the questions which are based on the conductivity of electricity. Then after this, one more concept is there, that is Arrhenius concept. According to Arrhenius, he gave definition of an acid. According to him, substances which dissociate into ions or they produce hydrogen or hydronium ions, they are known as acids. So it's a 1 mark question. How can you define acids on the basis of Arrhenius concept? And the answer is the substances which produce hydrogen ions or hydronium ions on dissociation are known as acids. So these are the questions which are based on these acids. Where we can use acids? What are their industrial uses? Where we can use them? There are certain industrial uses of acids. First of all, I'll talk about HCl. This is hydrochloric acid. It is a metallurgy item which we can use in dye stuffs also. We can use in dye stuffs, as you can see here, and in printing industry also we are using it. So this is first industrial use of an acid, and second is sulfuric acid, which is also known as king of chemicals, and it is used in fertilizers, it is used in paints, it is used in dyes, and it is used in detergents. The next is nitric acid, HNO3, that is nitric acid. We use in fertilizers again, and in explosives, dyes, TNT, trinitrotoluene. If you know this name, TNT. Okay. In this TNT we use nitric acid. And the fourth one is acetic acid. This is, you are very much familiar of this acid. We use in food as a food preservatives. So these are industrial uses of acids which we use in industries. Like HCl we use in dye stuffs, printing industries, sulfuric acid we use in fertilizers, paints, dyes, detergents, and we are using this sulfuric acid in so many areas. That's why we call it king of chemicals. Then we have nitric acid, which we use in fertilizers, dyes, paints, and it is also used in explosives. That one example is TNT, that is trinitrotoluene. And acetic acid, this is known as food preservative. So I hope these industrial uses are clear to everyone. And apart from this, We have boric acid also. Have you ever heard this word boric acid we use for eye washes? So, and oxalic acid. Oxalic acid is present in food items. It is used in ink stain remover. It is used as ink stain remover. So these are the industrial uses of acids. So I hope till here acid part is very much clear to everyone. So we have done physical properties, chemical properties, and how do they react, how do they conduct electricity, how can we define them, and what are the questions coming in exam on the basis of acids. Now next is bases. We are talking about bases. Bases properties are entirely different from those of acids. They are quite bitter in taste. They have soapy touch. And if you mix bases on litmus solution, or you put a drop of base on litmus paper, it turns red litmus to blue. So it's very easy to remember red to blue. Base starts with B and it always gives blue color. And apart from this, it gives hydroxide ions. In acids, they give hydrogen ions, but in bases, they give hydroxide ions in aqueous solution. So, and they can also conduct electricity because, as you can see, they also contain ions. So these are the properties of bases. They are bitter in taste, they are soapy to touch, they can turn red litmus into blue, and they can produce hydrogen ions, as a result of which they can easily conduct electricity. And examples of such kind of bases are sodium hydroxide, calcium hydroxide, potassium hydroxide. These are the examples of such kind of bases. Then we have aluminium hydroxide also. So many examples are there. So these are the properties of bases which I have discussed. Apart from this, bases are also of different types. First is, bases can be divided into two types, water soluble and water insoluble. So it means if bases can dissolve in water, we call them water soluble or alkalis. We call them alkalis. And the example of such kind of bases are sodium hydroxide, magnesium hydroxide, calcium hydroxide. And these are considered to be a strong base because they completely dissolve in water. Or we can say that alkalis, all alkalis are bases, but all bases are not alkalis. Because there are certain bases which cannot dissolve in water. Those are not alkalis. And it's again a one-mark question. Why all alkalis are bases and bases are not alkalis? Justify this statement. So in this you need to write the alkalis, the bases which are dissolved in water completely, and they are known as alkalis. But all the bases cannot dissolve. So that's why all bases are not alkalis. The next is on the basis of hydroxyl ions. The basis of hydroxyl ions or hydroxide ions, we have monoacidic bases, diacidic bases, and triacidic bases, similarly to that of acids. If you remember, acids are also these types: monobasic acid, dibasic acid, tribasic acid. So here also, on the basis of hydroxyl ion present in them, we have different type of bases: monoacidic, diacidic and triacidic bases. And examples of such kind is NaOH, which is sodium hydroxide, and this is calcium oxide, CaOH2. And example of such kind of tribasic is AlOH3. As you can see, it has only one. Its basicity is 1. It has 2 and it has 3. So these are the type of bases on the basis of their hydroxyl ions, and on the basis of their solubility we have two types: water soluble and water insoluble. Now next is chemical properties of bases. Like acids, bases also react with metals, and when they react with metals they produce salt and again hydrogen gas is evolved. So if an alkali, again alkali means the bases which are soluble in water. So those alkalis, when reacts with metal, they form salt and hydrogen. So look at the examples of such kind of alkalis, like sodium hydroxide, when reacts with zinc, which is a metal. So it results in the formation of sodium zincate. So sodium combines with zinc, which results in the formation of sodium zincate, and it takes up this oxygen here. Only this hydrogen is left behind. So it results in the evolution of hydrogen gas. And another example of such kind of reaction is when sodium aluminate and hydrogen gas are formed when sodium hydroxide reacts with aluminum metal. Look at the reaction, how it reacts. This is sodium hydroxide. So when sodium hydroxide reacts with aluminium and water, so it results in the formation of sodium aluminate. Here, water will not come now, and it results in the formation of hydrogen. Now this is how when bases reacts with metal, they also form salt and hydrogen gases evolve. Again, how can you detect the presence of hydrogen gas? Just bring any burning matchstick or candle near to it, and if pop sound is produced, it shows the presence of hydrogen gas. Fine. Now next chemical reaction of base with oxides of nonmetals. Oxides of nonmetals means when we have oxygen combined with nonmetals. Okay. Now those nonmetals are acidic in nature. For example of such kind is when carbon dioxide, which is a non-metal oxide, is dissolved in water, it produces carbonic acid. So here we have this reaction. And therefore when a base reacts with non-metal oxide, both neutralize each other. It means they cancel the effect of each other, they nullify the effect of each other, which results in the formation of salt and water. Or we can say that it's a kind of a neutralization reaction in which they nullify the effect of one atom. So when base react with oxides of non-metals, it results in the formation of salt and water. Or we can say that this kind of a reaction is an example of neutralization reaction. So here are few examples, like sodium hydroxide. When it reacts with sodium hydroxide when it reacts with carbon dioxide, which is a non-metallic oxide. So when it reacts with it, it results in the formation of sodium carbonate and water is produced. Again, another example of such kind is when calcium hydroxide reacts with carbon dioxide, it results in the formation of salt, which is calcium carbonate, and water is produced. Let's see here how it happens. So this Na combines with this CO and this one oxygen also, which results in the formation of sodium carbonate. And this H2 H. It has two molecules, H2 and one O. Combines with this, it forms water. Then here calcium reacts with this again carbon dioxide. It forms calcium carbonate and water is formed. So these two are similar reactions. These two are similar reactions, and these reactions are similar to those of acids also. In acid also same thing happens. Now apart from this, now if a neutralization reaction, as I told you, when acid and base combine together, they neutralizes the effect of each other. Neutralizing means they nullify the effect of each other, and it results in the formation of salt and water. That's why I am saying this kind of reaction is also an example of neutralization reaction. Because as you can see, here also salt and water is formed. And in neutralization reaction, products are salt and water. So the reaction between acid and base is known as neutralization reaction. And examples of such kind of reactions are sodium chloride and water when they combine with each other. So, hydrochloric acid and sodium hydroxide. This is base, this is acid. So when they combine with each other, they form NaCl. Na displays this hydrogen, combines with chlorine. It results in the formation of sodium chloride, which is a salt, and water is formed. Okay. Another example is when calcium hydroxide, again which is a base and this is an acid. So when they react with each other, it results in the formation of calcium chloride, which is a salt, and water is formed. Sometimes we feel indigestion after overeating, or when we eat spicy food, so our stomach gets upset. We feel acidity. So in that case, we'll take some antacid like milk of magnesia. So that contains hydroxide ions. That's a strong base. So when we take that antacid in the form of Eno tablet, so when we take that antacid, it neutralizes the effect of the acid produced in our stomach. Although HCl is already produced in our stomach, but to a certain extent, it is beneficial for us. It kills the bacteria which are present in our stomach. But if the concentration of HCl increases in the stomach, it causes acidity. And this happens because of the overeating or after eating spicy food. So in that case, to get a relief, we take strong base in the form of Eno, that is known as antacid, and which neutralizes the effect of strong acid and then nullify the effect of each other, and we get instant relief. So that's the reason why we are taking antacids in case of acidity. So that's an example of neutralization reaction. Now reaction of acid with metal oxides. See, as I told you, metal oxides are basic in nature. So when acid reacts with metal oxide, both neutralizes their effect. So again, acid and base, whenever they react with metal oxide or non-metal oxide, it always results in the formation of salt and water. And this type of reaction is known as neutralization reaction. So in both the cases, whether it is a case of acid or base, neutralization reaction takes place because we get salt and water in both the cases. And these examples which I have already discussed with you when I was discussing properties of chemical properties of acid. And if we are talking about what are the other things which are present in bases, in all the bases, there are certain similarities like acids. If you remember, I told you in acids, they have hydrogen ions. All the acids have hydrogen ions. Similarly, all the bases, when they dissociate, they produce hydroxide ions. So that's a common point in all the bases. Like acid. In acids, they all have hydrogen ions. In bases, they have hydroxide ions. And again, according to Arrhenius concept, how can you define base? These substances which dissociate and to produce hydroxide ions are known as bases. So this is the definition of bases based on Arrhenius concept. For example, KOH, which is potassium hydroxide. So when it dissociates, it produces hydroxide ion. Or take an example of MgOH2, which is magnesium hydroxide. Magnesium plus 2 hydroxide. Look here, this is mono and this is di one. It is mono acidic base and this is diacidic base. So according to Arrhenius concept, bases can be defined as when any substance dissociates into hydroxide ions, it is known as base. And again, there is a effect of dilution on bases. Similarly, if we are adding water in any base, so it becomes more and more, it becomes dilute. Its hydroxide ions reduces. So similar case, whatever we have observed in acids, here we are also observing similar case. If we are adding water into it, if we are adding water in base, its hydroxide ion decreases. Okay. So this is the effect of dilution on the bases. Similarly, in case of acids also, if dilution takes place, the number of hydrogen ions also decreases. So I hope till here it's clear. And if you have any doubt, you can ask. So these are the properties of acid and bases. And examples of hydroxides are here. See how can they dissociate. Sodium hydroxide, when dissociates, it dissociates into sodium ion and hydroxide ion. As I told you, substances which dissociate into hydroxide ions are known as bases. So we can say that sodium hydroxide is a base, and it is a strong base. Another example of such kind is potassium hydroxide. When it dissociates into potassium ion and hydroxide ion. So due to the presence of these hydroxide ions, they are basic in nature. And when acid and base, acid here because it contains hydrogen ions, and it's a base because it contains hydroxide ions. So when they both combine with each other, so it means when hydrogen ion combines with hydroxide ion, it results in the formation of water because it neutralizes its effect, and as we know, water is neutral in nature. It is acid, it is base. So I hope it's clear to you. Like when acid and base combine together, it results in the formation of water which is neutral in nature. Because when they combine, they nullify the effect of each other. They neutralize the effects. And applications of these neutralization reactions in our daily life we'll study later. I'll discuss those applications in detail, how this neutralization reaction is beneficial for us. One example I have already discussed with you. When you feel indigestion or acidity, in that case, we'll take Eno or any antacid tablet. So it neutralizes its effect. Okay. So these are the applications of neutralization reaction. So till here, I'll just wind up my class, and thank you everyone. If you have any doubts, please ask. So this is an example also I have discussed when sodium